So let's go through these real quick, and then I'm going to ask you to finish it at home. I want to do one little proof today with you of the next rule. Let's see which one of you work. So what would the derivative here be? Yeah, 5 comes down, power goes down by 1, start you off nice. Add just one little thing to it, but it's still the same idea. What's this going to be? So what would I do if I wanted to know the slope of this thing at 7? What would I do? Plug 7 into this. I like it. If I want to know what the point was at 7, plug 7 into that. So you got to be careful about which is which and what they mean. What about this guy?
16, that's 7 minus 9x squared plus 2.
Is that a minus or plus?
Plus 2.
Did I write down? So plus 2x?
Yeah.
I just wrote it down. Okay. And the minus 9, of course, the slope of any constant is 0. It's flat. Kick ass. All right, so far so good? Yeah. Now this one people get wrong really easy, but what do you get?
-15 -4.
Yeah, I always get somebody to do that for me, but it's negative, so when it gets smaller, it's going to get more negative. And then this guy,
3/2.
Who?
2/3 x.
the 2/3. The 2 minus 3 is -1.
Or 1/3.
And what do you do with f first? And I'm surprised how many people forgot this. Yeah, because where's roots on most plants? Don't my botanists jump up and say, well, for 2 words, the roots. No, screw that. Most plants' roots are on the bottom. So the root goes on the bottom, and the power is powerful, goes on the freaking top. So I haven't done the derivative yet, so now I say the derivative of this.
Now it's 7/6 to the 2/7.
That's a weird 7, okay. Alright. Oh, sweet. Okay, I got plenty of time. All kinds of time. So, that's nice. So our first little rule is easy. As long as you first put it in the right form, the rule will attack it. Just like putting y equals mx, simply getting it in the right form, slope and intercept jump out at you. It's sort of the same idea. Get it in the right form, and you know exactly what to do next. So, 2 things real quick. I'll talk a little bit more about this next time, but I don't know if you guys, a few of you guys know this already. E is one of the funkiest functions ever to exist. And we're going to go deeper into this, but it's one of the functions who is its own derivative.
Whoa.
Yeah, I know. So there's a homework problem where too many of you knew this, so you didn't actually do what it wanted you to. If you did this guy's slope, just think about what the slope is. What's the slope back here? It's almost what? It's almost 0, but it's not quite 0. It's always positive. It's always so it's tiny. It's tiny positive, and then going through here, it looks like maybe it's 1. So it's really tiny positive. What's happening to slope? It's getting bigger. So the slope is getting bigger, and it looks exactly the same. E is the only base that is exactly the same, right? So what we'll do, I desperately want to do product rule today, but then tomorrow we'll also talk more about what about things that don't have E as a base. What do their slopes look like, right? So we'll talk more about that tomorrow. Today I want to look at this. Let me make sure. I like it. Cool, man. So just to give you an idea of why I can't say that the product is just going to be the derivative of each piece. I'll show you very quickly how that doesn't make a damn bit of sense. What should this derivative be? Yeah, f prime should be and is 2x. But if you looked at it like this and said, oh, I'll just take a derivative of each piece, isn't that the same thing?
No.
That's not the same as that?
Yes, it is.
Yes, it is. Thank you. Okay. So then if you think this, well, that's weird, then its derivative of x squared is 1. So obviously the product rule is not take the derivative of each piece and then multiply it. That can't be it, because there's a counterexample. That's all I need to disprove an idea, is to show one counterexample. I'm done. So it can't have the same rule. So what the hell rule does it have? Well, too bad for you. I'm going to show you the derivation. So if you don't want to write this down, you don't have to. But I want to show you once in your life. Or once in your life. If I had, let's see. You guys with me? I want to figure out what the derivative of h is. And it's f times g. So how do I find the derivative of anything? Limit as h goes to 0. Now I told you you would never have to do this yourself, but we're going to have to use it. I think I said exactly this. We're going to have to use it to prove some other things. And here it comes. What the hell is this going to look like? What's the rule in general? It would be h of x plus h, right? So it's going to be f of x plus h times g of x plus h minus f of x, g of x, because that's h of x, right? Are you guys with me? H evaluated x plus h is this. Get over the double h's, it's too bad. And then h is fg all over h. Now this is where things get weird. And this happens more often in math proofs than you obviously know, because you haven't done math proofs. Let me back this up. We need some more room. So what we're going to do is something really freaky. And it's so freaky that I forgot exactly which order. There you go. What did I just do? What did I just do?
I'm too scared to ask.
Did I do it in the right order? Yes, I did. Yeah, I subtracted this and I added this. So did I just do anything? No, I just didn't do anything. I didn't do anything. Good job, Jeff. I did nothing. Right? But watch, this is kind of neat how this works. What can come out of these first two? F of x plus h, right? So then it would be g of x plus h minus g of x over h. Does that look familiar?
Yes.
You can read it? Alright. Plus, sorry. What comes out of here? I know, I'm sorry.
G of x comes out.
G of x comes out. And then you're left with f of x plus h minus f of x all over h. So as h goes to 0, what's this? Don't make too much of it. Don't think too hard. f of x. And what is this? What's the limit as h goes to 0 of this? That is the definition of derivative of
G of x.
g of x, which is also known as g prime, plus g times f prime. All right, so let's summarize what we just said. The product rule, that's the proof. That's the proof, and the one weird-ass place is right there, but you'd be surprised how many times we have to add and subtract the same thing just to make things organized into something more recognizable, just like it happened there. So what it is if I have a function that is a product of two other functions, its derivative, here's the cool thing. They each get a term. It doesn't matter, f prime, me first times, leave g alone, plus, now it's g's term. And the whole idea of they each get a term shows up in a few different rules, like chain rule, for example, right? Oh shit, some of you guys know what that is. It's in our future. Oh, it's the one people love. Right? If you don't know it, then you're like, I can tell from your tone, I'm gonna hate it. No, come on. It's awesome. Alright, so that's the first part of section 3.2. Not surprisingly, right after this we learn quotient rule. It's amazing. Oh shit, somebody knows a song. I hate songs. I'll show you. My song has 2 words in it, maybe. Yeah, 2 words. My song is 2 words. That's enough. Huh? Top first. That's all I gotta know, to do the freaking quotient rule. You'll see. Top first. Not quite in key. That's right, I hate songs. Yeah.